Hello everyone and welcome back. In this video, Logan is going to be revisiting the sprite class that we had put together previously. If you recall, we had put it together to support animated sprites, and then we had gone in and modified it just a bit to support what was the origin and all. Basically, we were working with the per pixel collisions.
Exactly. We needed a positioning system that was more convenient in use for gaming, and having a center-based position would make positioning everything in the game that much more simplistic.
Precisely. But now we want to get events tied into it so that, well, basically we have the ability to know when an animation has completed. So if we wanted to, let's say it was like an explosion. When the explosion was finished, we could have the sprite go away. So having an event get triggered would be, well, a perfect way to do this.
Exactly, because then we could actually drive animation in the game, or rather drive events based on animation, because our animated sprite is just that, it's animation.
That's right.
And it can be very helpful to time things to that animation because it'll make every event in the game feel more synced up to it. Because we have a certain amount of time that an animation could take place, though that time is based in a frame rate, not an actual time span. So it's hard to measure the sprite itself, but since the sprite is a timing-based class, we could just have it generate an event, and then everything can be synced up to visible animation.
Exactly. Now, this event will be using a custom delegate, so that's very cool. So basically, instead of starting out from a fresh file, I mean, it's going to be a fresh project, but Logan will be bringing in the sprite class that we have been putting together throughout this class.
Exactly, because we have been building on that class. The origin of the sprite class was to get sprite-based animation in general. We then revisited that class when working on per-pixel collision detection and making sure that animation worked with our per-pixel collision detection. So this is technically the third iteration of the sprite class. But I will be going back into that old project to get that very sprite class. And we'll put that into a new project because I want to keep all the elements that we create here very clear.
Okay.
So we're actually going to place the sprite class into a brand new game, keeping everything very simple. So we use our sprite class, we'll make a simple instance of it, but everything used to put the sprite together will be shown here in this video.
All right, sounds good. So let's go ahead and get started.
All right, well, the first thing we'll need is that new example project. So I'm going to start a new XNA 2 game, and we can call this something like, what do you want to say, sprite event loop. That sounds good. Sprite event, or sprite, actually, let me change that. Sprite loop event.
That sounds even better.
So this will be our sprite loop event project. I'm going to begin with a classes folder. And we are also going to need a texture, but I'll simply place that in the content sub-project. Now, the class that I want to bring in is, of course, that sprite class that we've been working on in past videos. And if I bring up my projects folder, I have placed the per-pixel collision project where we were working with the sprite class most recently. And if we jump into that, we have its classes folder, and there we have the sprite. So I could simply copy this into our new project, into sprite loop event, by pasting it into the Solution Explorer on our classes folder. So now we have access to that sprite. If we jump into it, here we have all of its code. Note the namespace, because I'll need to change that here in a second when I go to make a field. I'll save that for just a second, though, because just to make this follow a little bit more closely if anyone's following along, because that's a very easy thing to miss. Because if the namespace isn't the same as the namespace here in the game itself, it will look like we magically don't have the sprite for some reason.
Right.
Before I get to that, though, I do want to make sure I bring in the texture that we'll be using for the animated sprite sheet. And I have placed that texture here in our working folder. Just to reiterate, I'm going to go back and revisit this little test pattern sprite. The reason being is it has a very clear looping point. You can see that this little, what do you want to call it, arrow or circle goes all the way around the screen and then loops at the very top, making a very visible loop point. That'll be important because we're going to be working on a loop event. To get this in our project, I'll copy it basically the same as I had done with the class, and make sure we've got the content subproject selected and paste it into the subproject.
Very good.
All right, now that we have our assets, we have the sprite class brought in, we have the image brought in, the next thing I want to do is to set up this new game to be able to draw a simple sprite. Let's actually get a visible effect in place, and then we'll worry about the event itself. So what I want to do now is set up a few fields that will give me a sprite. I'll refer to it using a field. Make sure we get that created and drawing on screen. So the first thing we need to do is make a field in the class to store the sprite. So if I attempt to make a sprite field, you'll note that I don't have the sprite type, and that goes back to what I was saying a second ago. We brought the sprite class in from the per-pixel collision example where we had it placed within the per-pixel collision namespace. If I change this to our current namespace, sprite loop event, and then switch back over to our game, you can see that we now have the sprite type. So this will be our sprite field, and from here I'm going to move down into the load content method so we can get a new sprite created. So our sprite field will hold an instance of sprite, and as we initialize the sprite, we now need to feed in a texture and then some information about the animation itself, things like tiles and frame rate. The texture is going to come from the content manager, where we'll load the tile sheet asset. And we'll look at the content manager, not the console.
Not the console.
We'll tell our content manager to load a texture 2D, and the asset name will be tile sheet. Alright, next thing we need to specify for the sprite is the tiles X and tiles Y, number of tiles in X and Y. We have 5 tiles in X for this animation and 6 tiles in Y. The frame rate looks good at about 15 frames a second, and I will go ahead and specify a frame count because if you remember, that last tile is blank, it's just the color blue.
Right.
So that will wrap off the call to the sprite initialization. Now we can move down to update and draw. So make sure we get the update running so that the sprite does its animation, and then drawing so we see it on the screen. Now, as I go to update this, as a matter of fact, as I go to both update and draw this, I'm going to be a little bit more careful about the usage of the sprite. I'll just give you a little preview and just let you guys know that at the end of this lesson, I want to make the sprite disappear as one of the possible effects for the loop event. And in making it disappear, since I'm not using any kind of list and no other method is used to hide a sprite, I'm simply going to set the sprite reference to null. But of course, that wouldn't hide it. That would just crash the code if we were drawing it directly.
That's right.
So I'm going to be careful in drawing the sprite. And by that, I mean I'm going to check the sprite and make sure that it is not null before I attempt to draw it.
So you're just setting up for things to come.
Exactly. So if the sprite exists and is instantiated and is stored, then we'll update it. Running update and feeding in the game time. Now for the draw, we're going to need to look at sprite batch a little bit, of course. So we'll take our sprite batch and do the standard begin and end calls. And before we draw the sprite, once again, we'll make sure that the sprite has been set before we attempt to draw it. So if sprite is not null, then we'll tell the sprite to draw itself using the current sprite batch. And for now, we'll give a position of vector2.0. So all of that looks good. As a matter of fact, if all of that is working, we should be able to build. And if there are no errors, we should be able to run. And we see an animated sprite. But notice its position. Unlike the original animated sprite video, it is now half off screen. And this is, of course, because the sprite is now center-based in its positioning. We had made that change at the very end of all the per pixel collision lessons.
That's right.
Now, if we want to bring the whole thing back on screen, one easy way we could do that would be to offset by its origin. So when we give a position for drawing, we could actually give the sprite's current origin. So sprite.origin for the location, offsetting by the origin and placing the sprite fully on screen. So
cool.
Now we can see the whole thing. It is, in fact, updating and drawing. And one thing I'll point out really quick is we can very easily, if you want to say, hide the sprite, by simply leaving it null. That is, if we were to comment out the creation of the sprite, the code doesn't crash. So app is working just fine, but the sprite is now, for all intents and purposes, hidden.
All right, so now we're about to start getting into the meat of this whole video right here.
This is just a little bit of foundation we put together. So we have a simple app that has what we know to work actually up and working.
Okay.
Now what we want to do is take a look at adding a loop event to the sprite so that every time the animation restarts, we actually get an event fired back from that we can subscribe to and listen for. And that way we can drive things using the sprite's animation. So to set this up, I'm going to begin with the delegate that will be used in the sprite loop event. And I'm actually going to specify that delegate in a separate file just to keep things clean, because it is...
Let's talk about it for a second. Go ahead.
Well, with the way I'm going to declare this, it is actually rather general in its use. What I want to create here is a delegate that has no return, so void return type, and no parameters given to the delegate. And the reason I want to do this is I want to have something that will act as a very simple handler. Because, of course, the existing system event handler is going to be taking in the standard object, the standard sender.
Your sender and your events
and your event arguments.
Right.
And
you really want to slim this down.
Right. And of course that's very useful if you need that data. What I would like to have at my disposal is an event that I can look for and handle that doesn't require anything to be sent. I just want to know that the thing happened. I don't necessarily need to know information about it.
Okay, and you're also going to do this in a separate file now. Let's talk a little bit about that.
Right, because all of these things that we're creating exist inside the same namespace. It doesn't really matter that things like the sprite or this delegate that I'm about to create are in different files, but I do want to put it in a different file just to keep it separated from the code itself. Like I said, I'm going to set it up so that it's actually kind of general, and we will be using it in a later video, the same type of delegate.
And that becomes quite useful when you start having a lot of events by having them in one easy-to-go-to location.
Exactly, and it makes more sense if you have to go back and find and change the delegate, because to have it exist alongside the first class that it was needed for is just a little bit dirty. If it exists by the sprite class for no real reason, that could make it a little bit hard to figure out why the code is working like this. Why is it that this delegate happens to be right next to this class when other things in other classes and other code files are actually using that delegate?
That's right.
So putting it in its own file just makes a nice centralized place to add it. Plus, it gives a place to add any further delegates that you'd like to add.
Exactly. I said events a second ago. I meant delegates.
But you weren't too far off, because the file itself is going to be called events.
Exactly.
So if you wanted to read the whole thing in English, you could say that this is the file that's going to contain our delegates to be used for events.
Right.
Because as you'll note, I'm going to name this notify handler. So it's going to be used for an event handler, even though it's a delegate.
Right.
So in the classes folder, I'm going to create just such a file. We'll make a new item, and we'll call this events. So with our events, a few things to take a look at. First, of course, is the namespace. I'm going to strip off the classes subnamespace. Class is not going to be used. We're not actually making a class, so I'm going to wipe that out. Instead, inside of our current namespace, I'd like to declare the delegate. So we can go ahead and do that here. We'll declare this as delegate void notify handler. And notify handler will take in no parameters, so making a very, well, I guess you could say the most simple of simple method signatures. And I'm also going to take out all of our using statements since it's a delegate, meaning no actual code yet. So I'm simply going to wipe out all the using statements since we don't need any access to those types.
Just keep it as slim as possible.
And thinking about this, I really could have just added a blank code file here.
Sure.
Since I ended up essentially stripping everything except the namespace and just adding the delegate, but it's all to the same end. We would have arrived at the same end result. I do want to build and make sure that there's no simple syntax errors, but the build has succeeded, so everything is working. All right, now that we have this new notify handler delegate, I now want to turn my attention to the sprite class and add a loop event that is of type notify handler. So moving over to the sprite class, I'm going to jump down right before some of our first public properties. We can declare another public property. I'll make a public event of type notify handler, and we'll call this event loop. So we have a loop event. Now, what we want to do is, in order to fire off this loop event, we of course want that to be fired when the animation actually loops. So in order to find that piece of code, we're going to jump down to update, and it is inside of update that looping is actually handled. Looping in this case simply means the frame going from its current frame back to 0, though the way we're doing that currently is modulus, so that we modulus against the current frame count. So the moment frame goes over the end frame, it resets to 0.
Right.
The problem with this method is, while it's simple and efficient, it doesn't actually allow us, or doesn't notify us that it happens. It's just a property of the way this is working numerically. So what I'm going to do is I'm actually going to change this resetting of the frame to an if statement, and because it's an if statement, then we have a conditional branch that we can actually fire the event handler from. So I'm actually going to erase this line of code and begin an if statement. And what we're checking for is to see if frame has gone past the current frame, or which we're treating. I was going to say end frame. We haven't actually declared the name end frame here, but we have a frame count. So if our current frame is greater than the number of frames, then we've actually reached the end. And so it's that reach the end thing that we're detecting for. So we can check the frame. So if this dot frame is greater than this dot frame count. Now I've got to keep in mind that frame is 0 based, frame count is 1 based, so I'll subtract 1 from frame count so that everything lines up. And now if this case has been reached, that means we now need to restart the animation. So the first thing to do with that is to set the current frame to 0, and that will allow our animation to restart. Now, since this is a conditional branch, this is also the perfect place to fire off the loop event. Now, before I directly fire that off, I do want to make sure that the loop event has been set, as I don't want to attempt to use it if it's uninitialized. So we'll first do a check and say if this.loop does not equal null, or excuse me, if this loop, oh yeah, that's right. Yeah. For some reason I had read that as equals null. I'm not sure why.
I got you.
But if the loop event is not null, meaning it is assigned, then we'll go ahead and invoke it. So we'll say this.loop to allow any necessary events to be fired off. With that, I guess it couldn't hurt to do one more quick build just to make sure that everything in this file is looking good syntax-wise. And now we can return to the game and take a look at what this can be used for. Now, before I hook up the event, I first want to create something for it to do. And what I want to have happen to begin with is we'll set it up so that every time our sprite loops, we change the background color a little bit. And in order to make the background color changeable, I'm going to store the background color in a variable. So I'll make a color variable that I'll call background color. And we can go ahead and initialize that to a value of color.cornflowerblue. Just stick with the default color. But then, of course, we want to make sure we remember to go back into the draw method and use that background color value. So now that we have a background color, it would be very easy to change. So I'm going to jump in right above our constructor and make a new private method. Now, this method, we're going to make sure that it matches the delegate's signature, because this is the actual method we want the event, the new loop event, to invoke. So that means we need things like a void return type, and we need to make sure that there's no parameters. Now, the name for this, we can call it something like change background. And again, no parameters. And in order to change the background color, I want to set up something that can happen over and over again. I don't want to have to use if statements to switch back and forth or to toggle.
Sure.
So what I'm going to do is I'll have it simply take the red component of the background color and advance that, increase it. So we'll take the current background color and we'll reassign it to a new color, but we'll base that color off of the background color. So if we simply wanted to copy all of the values, that would be something like background color.red, and I'm going to specify these on separate lines. Background color.green and background color.blue. So those would be all the components simply feeding back into the new color. But like I said, I want to take red and increment it by a value. Maybe 64 will be a noticeable change each update. Now, of course, this mathematic operation is going to result in something other than a byte, so we'll take the whole operation and cast it to a byte. Then everything should work well there. I will build one more time just to make sure that we can continue from here. No errors. So let's hook up the event now. If we scroll down to the load content section where we created the sprite, we can now turn around and look at our new sprite and set up its loop event. So we'll say loop, we'll subscribe to loop with a new notify handler. And the method we would like to use with this new delegate would be the change background method. So with that, and if there are no errors, we can go ahead and run and watch the sprite. And upon loop, the background color changes.
Very nice.
And again, and again. Now notice what just happened there. I switched back around to blue. So all that really happened there is we overflowed the byte, and it wrapped back around to a small value.
Right.
But again, I was actually going for that effect because now we can monitor the effect as much as we want. And we don't have to worry about running out of color or exceeding something. So all that is actually working very well. We can now drive, at this point, we're driving the color of the background by the sprite's animation. And this could, of course, be more interesting if we had a more in-depth code base behind this example. If we had the ability to spawn fireworks, you could have lots of particles spawn every time this hits. But for the time being, this does show that we are, in fact, getting an event. We're getting notification of the fact that our sprite is looped.
That's right.
Now, one other thing that's kind of cool to show here is something else that's useful when working with sprites, and that is if you are using the animated sprite to drive an effect, like an explosion, it can be very useful to set up a scenario where the sprite is destroyed after the animation finishes. Because if you have the explosion, you want that to be more of a one-time effect. And at the moment, we don't have that concept implemented in Sprite. But since we can tell when a loop occurs, that also gives us something else. It's almost like a 2-in-1. The loop also means that the animation is about to restart. Knowing that, if it's about to restart, that means that it's at its end. Which means if we wanted a one-time effect, we can simply cause the sprite to go away, and then we'll get just such a one-time effect. To show that here, I don't have a what you would call an easy way of hiding this, where in the past we would remove things by taking them out of whatever relevant list they belong to. Though here, since I have set up the code to be somewhat durable and allow drawing even if the sprite is null, we could just set the sprite back to null, and that will cause it to disappear. So to do that, let me make another handler method. So we could make another private void method, this time called removeSprite. And inside of removeSprite, we could simply set our sprite reference equal to null. And now, if we go into our sprite and change the notify handler to removeSprite, you can watch the sprite, and as it hits the end, it goes away. So had that been an explosion or an effect or anything we wanted to animate only once, it's done just that. It reaches the end and ends off there. Now, of course, the cool thing is, if we wanted more than just the sprite to disappear, we could go in there and set up multiple handlers for it. We could go and use both change background and remove sprite, so we get some arbitrary effect and the sprite goes away. So still a lot of power available there. And I mean, with that, that really wraps up what I wanted to cover in this video. Again, just showing where some of these delegate and event concepts could be useful to us in the creation of Space Fighter. That's why we've gone back and looked over our sprite class and enhanced it a bit so that we can have a loop event. So we're putting both a custom delegate and then an event handler in place so that we can be notified of whenever any sprite reaches a loop point, whenever any sprite restarts. So with that, I guess that wraps up this video.
Okay. Thanks a lot, everyone.